Hey guys, today I would like to talk about this new interoperability feature of Xcode 15, which helps you with mixing your C++ and Swift code without Objective-C bridging layers. Initially, Swift was designed to be interoperable with Objective-C, which is a C-based language. This was crucial because many iOS and macOS applications were written in Objective-C. Before this feature, integrating C++ code into Swift projects usually required a bridging layer. This typically involved using Objective-C as an intermediary, which added complexity to the development process. Additionally, imagine how complex and time-consuming process you would need to go through when creating these bridges. But now, we don't need a bridging layer. So first, I will cover the basics of how you would interact with C++ through bridging layers. After that, I will demonstrate how to make it work the new way. So let's get started with creating our project and framework. We are creating our project and we are choosing the storyboard interface, and then we can choose the language of Objective-C. Afterwards, we are creating our framework in the project. The language should be Objective-C again, and you should choose project of MathView, then embed it in the application. We will have this folder structure after creation, as you could see. And if you were to continue with the bridging layer and view creation, which is going to happen before we create our C++ files and functionality, we need to navigate inside the MathView folder and create Math Operations view, which is going to be a SwiftUI view. Then you will be presented with this pop-up. So you need to click on Create Bridging Header, and then you will be given these H and MM files. Move them to our MathOps framework and make sure you have selected the right target. If you want to follow my file names, I have changed my bridging layers file name to Math Operations Bridge. So we go to our target and build settings, then search for bridging. Then we will be seeing this Objective-C bridging header source name and where it's located. So we need to change the file name, and then our structure is going to look like this on the right side. So let's introduce C++ to our project now. As you can guess from the project name, we are going to be doing some math operations such as adding, subtracting, multiplying, and so on. I wanted to keep it very simple. Well, I'm not really an C++ expert. I've seen some, fundamentals in the university, but anyway. So let's start by creating a C++ file. We will call our file math operations, which will have the extension of CPP. Also make sure that you select this option, which is creating the header alongside, and it will have the extension of HPP. So basically these headers that we will see and implementation classes are going to be basically protocols and implementations of protocols. Let's continue with implementations. So as you could see, we have these lines square, if def, C++, and at the end we have this end if. The reason behind that is that we make sure that class is only compiled under the C++ environment. And then we create our class, which is going to be public, containing these static functions. So we can directly access these functions from our bridging layer without any initializing and stuff like that. All right, so we are continuing with the CPP file. CPP file is basically what we would do in Swift with protocols. After we were creating the protocols, we would do the implementation. So this is literally the same thing, nothing really different. And the concept, or let's say the code, is really simple here. A plus b, a minus b, and so on. So we could continue with our bridging layer. We are going to check what's going on in the MM file first. So you will have this implementation operations bridge, and we will be importing the math operations bridge header file again, which we didn't look at now. Then we are going to include this math operations.hpp file, which is going to include all of these protocols of C++ code that we just created. And then if you look at the implementations class, we are going to see in the return types, we are calling these static methods that we created before with C++ code. In the header layer, we are going to have this importation of foundation, and then we are going to see this NSAssume non-null begin and non-null end. What these macros are going to do is tell compiler that unless there is an explicit mention all pointers in this interface are assumed to be non-null. It's a way of saying I expect all these inputs to be actual values and not null or nothing. So this was everything we needed as far as bridging of Objective-C and C++ code. Oh, actually there's one more thing we need to do, which is updating our metops H file. This is basically the end game for the bridging. Here we are importing the metops met operations bridge H, and then we are also including the met operations HPP. So we navigate to our view now, and we are importing metops. Make sure you have added this module to our project as a target. It's an important point. And then since the bridges layers methods are static, you can directly call them like this, and you will see the result on the right side. That's pretty much it with the bridging layer. Now we are going to remove this bridging layer and see how we can directly access with the interoperability of new Xcode. First, we are going to go to targets, build settings, and search for interoperability, and you will see Swift compiler language, and we want to change this from C, Objective-C, to C++, Objective-C+, for both of the targets, including metops. And afterwards, we want to tell Xcode we are not using any bridging layers, so you could, go to the target build settings, search for bridging, and remove the source that we have created, or anything, just leave it as blank. So next, you can go to metops H file, and you could remove that line of importing the bridge headers, and it's going to look like this. So we are telling our compiler, hey, we don't need this bridging layer anymore. And you can directly work with this C++ code. And if we can navigate to our view and directly call the C++ code, we could see that we no longer need to call any bridging layer, and we are getting the same results also. That was pretty much it, guys. If you have a large amount of C++ containing code base, you can gradually update your code by getting rid of these bridging layers. But obviously, you need to keep in mind that this is an Xcode 15 feature. So, right. Thanks for watching, guys. Merry Christmas to everybody. Goodbye.